Good afternoon, student. In last class, we have seen the basic definitions of collision, in which we discuss about elastic collision, non-inelastic collision. Now we see further, in which the topic is elastic collision in one dimension. Elastic collision in one dimension. As we know that what is one dimension, if and in a three coordinate, if any one of the coordinate specify the position of the object, is known as one dimension. Okay, now here this is your having any body whose mass is m1 and u1 is its initial velocity, and another object, it is having mass m2 having initial velocity u2. Okay, so as we know that first, what is a momentum? Actually, it is the impact due to combined effect of mass and velocity. This is a combined effect of mass and velocity and denoted by P, and it is equal to m into v. This is known as momentum. Okay, this is known as momentum. So now we proceed in our topic, and we see that when these two bodies having mass m1, initial velocity u1, and m2 mass having initial velocity u2. Now if they collide, then such situation will occur. This one is having mass m1, this one is having mass m2. Now when these two bodies are collide each other in a same straight line, so what will happen? There is a principle which we have last time discussed, and that is law of conservation of momentum, and in which now we see after collide these two bodies, they are move along the same line, but velocities are changes after the collision. It is suppose it is having velocity v1 and it is having velocity v2 after the collision. Now we apply the principle of not first m1 is what? It is the mass of the first body, m2 is the mass of second body, and u1 is the initial velocity before collision, and u2 is the initial velocity before collision. Now we see next, and v1 is the velocity after the collision, and v2 is the velocity of the body b after collision. This is of body a. This is for now. The masses before the collision and after the collision are not changed. So what does it means? So linear momentum of the two balls before collision we can write. Now we write linear momentum of the two ball before collision, and it can be written as I have defined momentum, that is the product of mass and velocity. So now we write for this first body, this is first, this is second body. So it is having mass this one, velocity u1. So we will write m1 into u1 plus m2 into u2. This is the linear momentum of the two. We have taken the ball, that's why this is the total momentum of the two ball before collision. Now we write linear momentum of the two balls after collision. So it will be written as m1 into velocity v1 plus m2 into velocity v2, because after the collision, this body, this is the state of collision, this is during the collision, and after the collision this one will be the stage, and v1 is suppose moving with some velocity in this direction, and this body also moving in such any direction in this direction. Okay, so this is the m1 into v1 plus m2 into v2, it is the momentum after the collision. So as we know, and as I have discussed in the last class, that linear momentum is conserved in elastic collision. Okay, so from these equations we can write m1 into v1 plus m2 into v2. This is the linear momentum after collision, and this is the linear momentum before collision, plus m2 into u2. Now we can further write this m2 into v2 minus m2 into u2 is equal to m1 into u1 minus m1 into v1. Okay, and this can be further written as m2 v2 minus u2 is equal to m1 into u1 minus v1. Okay, this is our equation number first by the principle of conservation of linear momentum. Now we write second thing, that is total kinetic energy during the elastic collision, as we have discussed, is not change before the collision and after the collision. Total kinetic energy of the two ball before collision and after collision, it can be written as half m1 u1 square plus half m2 u2 square, and again we can write total kinetic energy of the two ball after collision is half m1 v1 square plus half m2 v2 square. Okay, here this is I have written. Okay, here. So this will be, as we know that energy, kinetic energy remains conserved before and after collision. This can be written as half m1 into v1 square plus half m2 into v2 square is equal to half m1 into u1 square plus 1 by 2 of m2 into u2 square. Okay, now this can also be written as m2 into v2 square minus half m2 into u2 square is equal to half of m1 into u1 square and minus half of m1 into v1 square. Okay, now this can further also written as m2 v2 square minus u2 square, and it can written as m1 into u1 square minus v1 square. So we get equation number 2. We write this equation number 2, and now we have to follow a step, and that is divide equation number 2 by, means इस सेकेंड इक्वेशन को डिवाइड करना है first say. So we write equation 2. This is m2 v2 square minus u2 square, and this one m1 into u1 square minus v1 square, and our first equation is this one. This is our equation number first. Okay, so dividing second equation by first equation, so this will be divided by m2. This is v2 minus u2, and here m1 upon u1 square minus v1 square. No, this is u1 minus v1. Okay, further we can write this m2, and this m2 got cancelled. Here m1 and m1 got cancelled. Now this can be written as v2 minus u2 and v2 plus u2, and it is divided by v2 minus u2, and here u1 minus v1 and u1 plus v1, and it is divided by u1 minus v1. So these two quantities got cancelled. This is also got cancelled. So we get only v2 plus u2 is equal to u1 plus v1. So v2 can be written as u1 minus u2 plus v1. This is the value of v2. This is our, we named it equation number third. Now we substitute the value of v2 for the calculations for finding the velocity after the collision. Our aim is to find that after the collision the both bodies will move with how much velocity. So we, our purpose is to find the velocities after the collisions of the two bodies. Okay, so here we get a relation in terms of v2. Now we put this value of v2 in our equation number first. Okay, note down, follow that, put this value got it in third equation, put in equation in first equation, got it in third equation. Okay, now as we know our first equation, that is m1 into v1 plus m2 into v2 is equal to m1 into u1 plus m2 into u2. This is our first equation. Okay, now we put this value of v2, this one we put over this value into v2, so we can write m1 into v1 plus m2, and v2 is replaced by u1 minus u2 plus v1 is equal to m1 into u1 plus m2 into u2, and it can further written as m1 into v1 plus m2 into u1 minus m2 into u2 plus m2 into v1, and this will be equal to m1 into u1 plus m2 into u2. Now we get v1, it will be equal to m1 minus m2 into u1 divided by m1 plus m2, and we get twice of m2 into u2 upon m1 plus m2. This is the value of v1. So it concluded that that after the collision the body A will move with this velocity. So this is the velocity of the first body. Now we have to find the velocity of the second body also. So velocity v2 we don't know right now, so we have to find the same value of v2 we have to find the value of v2 also. So what we do, we get this one in the equation number third, that is u1 minus u2 plus v1. This one we get in equation third. So we put the value of v2 is equal to u1 minus u2 plus this one is v1, and we get this v1 here also. So we substitute the value of v1, that is m1 minus m2 into u1 divided by m1 plus m2 plus twice of m2 into u2 upon m1 plus m2. So after solving, we get v2 is equal to u1 into 1 plus m1 minus m2 divided by m1 plus m2 plus u2 into twice of m2 divided by m1 plus m2 minus 1. Okay, this is value of v2, and further we can write this value of v2 is equal to twice of m1 into u1 divided by m1 plus m2 plus m2 minus m1 into u2 divided by m1 plus m2. Okay, so it concluded that it is the velocity of the second body after the collision. So in our today's class we have seen that when two bodies are having some velocity, initial velocity, having some masses also, and by the law of conservation we know that masses remains constant during the before the collision and after the collision, and total kinetic energy also remain conserved in case of elastic collision. So by using these two laws, after that we have find the value of first body and second body after the collision, and it is given by v1 and v2. Okay, thank you. In our next class we will see further. Okay, thank you.